Oh, hello, welcome back to the shop. It's good to see you. Those of you who've been following my channel will know that on my Sally the Sile mill, CNC mill, I put a power drawbar and I use Tormac style. They're not Tormac, but they're Tormac style tool holders that I make myself. And I've been wondering, is it possible to actually put through spindle coolant through one of these things without having to modify the spindle in the mill? So roll the titles and I'll explain why. Firstly, I've been, if you've seen the last video, you'll see I've been hogging out material off some blanks to make some tool holders. These two have been done to the point where the spigots are absolutely spot on and they've been counterbored to clear the end of the R8 collet. So now I'm clear to bore them and shape the front to make actual tool holders. So let's move on. Several years ago I bought this. This is a carbide insert 10mm end mill, and it came with a little insert that's intended for general purpose, generally for cutting steel, and everything was hunky-dory for about 10 minutes. Then I broke it, and ever since I've been thinking I really need to make another one, because these are expensive now. The last time I looked, I think these were about $140 or something, and I'm not spending $140 on a tool that I'm going to break. So what I've done is I've bought some new inserts. These are intended for aluminium. I think a lot of model engineers, myself included, find that the inserts designed for aluminium work quite well on steel as long as you don't push them too hard. So and you get lower cutting forces because they're sharper. So what I'm going to do is make a new tool for these inserts, and this particular tool has through spindle coolant, and I thought to myself, I wonder, can we actually do that with one of my Tormac style tool holders? So I'll just go and get the tool that I'm going to make something very similar to show you. Right, here we are. This is the tool that I'm going to replicate, except I'm going to make it with one insert rather than the three. This is an absolute beast. It can absolutely rip metal off as fast and as hard as my mill is capable of doing it. So this was a cracking make several years ago, and what I'm going to do is use one of these new blanks to make a replacement, but like I said, with a new a proper milling insert. These are the standard triangular CCMTs, I think, inserts, and this is, oh, what's this called? This is an APHT style. So making a single cutter version might actually be quite a good thing to do, but be nice to have through spindle coolant. That's why we're here. My first attempt was to design something in CAD and 3D print it. Whoops! And this was the result, and it is truly awful. The holes were blocked up. I drilled them out. I drilled straight through it a couple of times, and it's absolutely useless. So let's get rid of that. So I had another go and printed it more accurately, and this is what we've got. This is a complete copy of a full tool holder. So as you can see, it should just fit straight in the spindle, and we can try it out. The object is to point the coolant hose. Touch of the shakes today, I need a beer. And these holes should pick the fluid up, the coolant up, and direct it into the centre of the tool, of the holder, and then out through the bottom. The problem with this is, as soon as the coolant hits this tool and actually enters it, then centrifugal force is trying to throw it out again. So consequently, the internal shape of this has to be spot on in order to drive the fluid, drive the coolant into the centre. So we've got this one to try. This is the least likely to work, but we'll see. I also had another go because of the geometry of how the coolant hits it and has to be driven in. This one has proper flutes in. This I think is more likely to work. However, it's an absolute bugger to manufacture because it'd have to manufacture the spigot and the body separately, then silver solder or braze them together, and then finish them all to size. So that's adding another couple of operations to an already painfully slow tool holder to manufacture. So this is more likely to work, but I'm less likely to build it. Which led me to this. I have got this is a knackered tool holder. I overbored the hole in the end, so it's too big. So what I've done is put a reduced section on it and put some radial holes in straight through into the centre, and I've 3D printed this yoke, which fits on there like so. Once it's clamped together, will allow it to rotate, but you shove the end of your coolant hose in there, and that should theoretically just drive coolant straight out the end, regardless of what the centrifugal force is. And this doesn't need to be a very good fit because it doesn't matter if it leaks. To some extent, it's a reasonable idea because there's oil in the coolant that will help lubricate it. So having some coolant dribble out is actually no bad thing. So let me screw this together. Let's go over to Sally the Sile and we'll give them a go. I have reduced the drawbar pull in order to not crush the spigot on these plastic 3D printed parts. So let me just open the drawbar. Alright, let's try this first one. Hope for the best. Okay, that seems to spin. So let's turn the spindle on. Right, that's good. I know one or two of you have commented in the past on my sort of intermittent view on health and safety, so I have taken a precaution. So here goes. Spindle on, coolant on. Yep, that's not a worker. Right, that's the problem with the centrifugal force. Let's take that one out. And put the one that's got proper spirals in it. That'll do. Spindle on, coolant on. No, that one's duff as well. See, that's the thing. While it's stationary, it absolutely is. This stream is coming out of the central hole. So let's try it with a really slow spindle speed. Yeah, that's still coming out. And then it sort of stops. All right. Right, let's try the one with the saddle. Oh dear, that should be a snug fit in there. Right, more tape. I know what I've done. I've measured the diameter of this and turned it into a radius there. Yeah, nupty, I know. Bit of tape and we're good to go. It's a few days later and I've finished making all the spigot ends of these tool holders and I've tried them all in the machine, so they all fit nicely and as accurate as I can make them. This one is the tallest one I've got and I'm going to just take it down to these dimensions so that I can turn it into a new cutter. I've roughed out the blank for this new tool, so let's put it in the mill and start to cut out the business end. There we go, that should do the job. I don't want to put too much pressure because I don't want to deflect it. I've put in the first tool, and now I just need to touch off on the top here. Then I can work out exactly the right Z height for the tool. My G54 is right in the centre line, so I need to measure the diameter accurately and then put in a manual offset for the height. But first I need to establish the distance between the bottom of the tool and the top of that workface. I call that 0. 0 my Z axis. Select that axis, then type in 18, enter. Now we are correctly set. Cycle start, off we go. Right, that's going to take it another 7 or 8 minutes, so let's catch up when it's closer to the end. I've changed the tool to a high-speed steel 3-flute 6mm ball end mill. So now we're ready to take out the rest of the material around this hole. So my son, bless him, is going to press the cycle start button. I have, you'll see this in a second, I've changed the tool just up here to a 2.5mm 3-flute high-speed steel cutter, and it's time to cut the pocket out in here for the insert. So cycle start, here we go. Right, so we've machined the pocket for the insert. Here's the insert. Just put it on, see if it fits. It does. However, it's too far out of the bottom. I don't quite know what's happened there. That's 2.9mm further out, further that way than it should be. So I think I'll just go to back to my CAD program and find out exactly what the problem was, and then I'll remachine it, just push it a little bit further that way, so just repeat the same operation with an offset. So let me go and find out. I've recut the hole. In fact, I had to move it 2mm that way and 1.5mm that way, so I don't quite know. I did this operation on the day after I cut the main pocket out, so there's every possibility that I lost the exact position. So here's the insert, just put that in there. That fits an absolute treat now. So next up, and the last operation for this this current setup, and then we can try it, is to drill and tap the hole to hold the insert in. So let me get on with that. This is the best way I've come up with trying to get the screw hole in a position. You'll have to let me know if I've done this as a complete numpty, but we'll see. This pin that's in a Jacob's chuck is a snug fit on the hole through the insert. So what I'm going to do is lower that down. Let's move the Y until it's just above there we go, just above the surface that it, the register surface for the back of the insert. Jog it off. Okay, so I've got to go Z as well. Sorry, X as well. There we go. Now I should be able to drive that on. There we go. Now if I keep fiddling around, I should be able, there we go, that's tight that way, so let's go to X. You can see that, you can see what I'm doing. I'm trying to push the insert right into the corner without deflecting this pin. Righty-ho. I'll have a little look at that off camera just to make sure I'm there. A bit of splodge in the hole. M3. Right, the tool is now loose, but should be concentric, so I can spin this in by hand very gently. We are done. Let's take this out and see what it looks like. Well, there we have it. One cutter with a nice seat in it. Quite chuffed with that. So on with the next stage. Excellent. I will just shorten that screw a little bit. Here we are on another day, and overnight I printed out 2 yokes out of this is PETG with carbon infill, so they're basically, these parts should be as good as aluminium, so I'm led to believe. They are 2 yokes that are going to fit together like so. Push your coolant hose into one side. They're both blind at the moment, these holes, so they're identical parts. I just need to open one of them out so that the coolant can flow in, and they're identical, so that if you don't use through spindle coolant, this could probably just sit on the tool holder and spin without having any balance issues. Hence why, like I said, they're identical. They're held together with 2 4 tiny little neodymium magnets that are going to fit in those little pockets at the end there. I'll give you a close-up of that so you can see that. But yeah, I need to clean these up, and then we put this tool holder back on the lathe and cut the slots. Then the last job is over to the mill to drill the radial holes and the hole down the end. Right, I've cleaned them up, run them on the part and glued the little magnets in, but these are not strong enough. That falls off really easily. So I've got some slightly bigger magnets. I'll fit those. Right, we're getting close now. I've cleaned the yoke up, drilled a hole through for the coolant to get into it, fitted some more powerful magnets. Still not convinced, but we'll see. And I've drilled radial holes. I managed to break a drill off in 2 of these holes, but there's 6 of them, so 4 of them should be enough. But because I broke the drills off, I then had to bore the end. So I've drilled through the end and then used a carbide end mill to just, in the lathe, just to push through the remains of the drills. So I'm now down to that depth, roughly, which means I just need to punch a little hole in here to let the coolant out of the bottom and then plug the hole. So I had a look at the tool that this is based on with through spindle coolant. I'm not going to reinvent the wheel. I'm going to use the same diameter hole. That's 2.5 mil. And I don't know if it... Hello, it's a cat. I don't know if it comes over very well, but that is lined up so that it leads the cutter. So I'll attempt to do something similar to that, but we'll see. Don't like coolant. But we do like a chin rub. I've put a piece of bar in the front T-slot on the mill, on the table, and so the vise is now canted up by 3 or 4 degrees. So hopefully what I was trying to do was avoid chopping into this edge up here. There you go, no more chips. I think we must have broken through. Just for giggles, let's just put the coolant on and see what happens. Well, it's definitely coming out of a hole. It's coming out every bloody way, to be honest. I'm covered in it. Right, so here it is. There's a little hole in the just off the centre that directs the coolant towards the tool. I've refitted a tool. Off camera I also bunged up the end with a bit of brass slug so that it doesn't leak backwards into the spindle. These bits, these yokes, are going to leak like a sieve because they don't even line up properly anymore. I think they kind of moved, to be honest, but anyway, that might get better as it wears. So yeah, over to the mill and we'll try it out. In the mill I've bolted it in. You can use it as a standard cutter with the coolant directed to it as you would normally do, but with the addition of these yokes you push the coolant hose in there, and let's start it off again. There we go. So now, in theory, it should blast some of the coolant. A lot of it's going to come out of here, I would have thought, but let's give it a go. I'll tell you what, let's start stationary, then we can see if let's turn the coolant all the way down. Coolant on. Right, so oops. Probably, yeah, it leaks a bit like a sieve, but there's a jet coming out there. How cool is that? It's going to throw it every bloody way. I tell you what I'm going to do, before I actually try cutting any metal with it, I'm just going to run it for 20 minutes or so with coolant running through it, and the spindle running. Hopefully I can bed these two yokes in a little bit. I've been running it for a while, and let me just turn the coolant on. It still leaks like a proverbial sieve at the top here, but yeah, it doesn't really matter much. But you can, there you go, there is indeed a coolant stream coming out of the central hole. So I'm chuffed about that. The only thing to do is to try it. We're under CNC control, so let's go M3 speed 1000. It's got a bit quicker than that. Speed 1300. Coolant on. There we go. Now let's go G1X minus 100 at feed 40. Go. See if it makes a reasonable cut. Blimey, that's quiet. Barely hear it cutting, but there's plenty of chips coming off. Yeah, reasonable finish, I have to say, for the first attempt. Apologies for Timmy the tumble dryer next door, but let's do a bigger cut. So let's go with M3 G1Z minus 2. Okay, now G1X0 feed 80. Now this, oh, turn the flood on. Enter. Well, there we have it. That's not a bad finish, is it? Quite chuffed with that. So there we go. Is through spindle coolant worth it in the home shop? I don't know. Tell me what you think. Leave a comment in the doobly-doo, and we'll be interested to see what people think. I think if I did want to pursue it any further, then I'd have to machine some proper spaces up here with bolts that go through to clamp it, or I could 3D print another set. Maybe I'll do that just for fun, but you don't need them. It operates quite happily as a normal tool. So yeah, thanks for watching. See you again on the next one. Stay safe and take care.